This is Ms. Fitzmaurice, and this video is about two-dimensional kinematics. Okay, so hopefully by the end of this video you will have started thinking in 2D. Normal life is in 3D, but that's a little too advanced for us at this point. I'm going to show you an example problem of 2D kinematics, and then you're going to try one yourself. Okay, so the basic idea of 2D kinematics has to do with vectors. Okay, say I have a ball and I throw it up into the air. Everywhere it goes, I could make a grid, I could make some graph paper, and as the ball travels, it's going to have an x-coordinate and a y-coordinate. So pretend you're in math class. This is your y-coordinate. This is your x-coordinate. And you could give two different numbers to tell you about the position of your ball as it flew through the air. So the basic idea is you break everything up into x and y coordinate. So we know that x is position, but strangely enough, we're going to start saying xx and xy. Okay, so xx is like your horizontal or your side-to-side position. And xy is your vertical or up-down position. And we don't just break we don't just break our position up into x and y. We break our velocity up into x and y. So we have vx and vy. We break our acceleration up into x and y, ax and ay. And time is the only thing that doesn't get broken up. Okay. Before you watched this video, you probably watched the video about vectors, and if you didn't, you need to stop and go back and watch that one. But if you think about it, everything you break up into an x part and a y part is a right triangle. Okay, so if I told you the total velocity, say the total velocity of this ball that I threw up into the air was 10 meters per second, you could find, with an angle, you could find Vx and Vy. Okay, so as we go through this, keep that in mind. That's what I mean by thinking in two dimensions. You're not just thinking about things moving up and down and side to side, but you're thinking about breaking the movement up into up and down movement versus side to side movement. Alright, so the next thing that I want you to do is I want you to take out your packet and turn to page 5. And you have something that says on the river. At this point, you should probably pause this video for a minute and click on the other link that is on the homework site today. That takes you to Mr. Maloney's simulation that shows you a boat crossing a river. Okay, so my friend, he made this simulation. He teaches AP Physics and regular physics at a different high school, and you can use this simulation to sort of start to think about 2D motion. Okay, so I want you to close this video, open that up, and just play around with it, and then try to answer the questions on page 5. Once you've done that, come back to this video, and we will discuss the questions together, or I will tell you the answers. Okay, so now that you've gone ahead and you've tried that, we're going to talk about the answers on page 5. First question asks, what do you expect the boat to do if the river, and that's the downward direction, so I'm going to draw a little picture of the river's going downwards, is equal to 0, and the boat equals 2. So in that case, we expect the boat to just move straight across at 2 meters per second. and I'm just going to write a sideways arrow. It's just moving straight across. On the other hand, what do we expect if the river is going at 2 meters per second and the boat is going 0? Then you would expect your boat, okay, the boat motor's off, it's not crossing at all, but the river is pulling it down, so the boat moves straight down. Okay, so in this case, the boat's motion, the motor is our horizontal. Okay, this is our horizontal motion, and the river gives us our vertical motion. Okay, number 3, what do you expect to happen to the distance between dots? And as the boat moves across the river, it leaves a dot every second if the boat gets faster. And the answer is the dots are spread further apart. And that's supposed to say spread further apart. Okay, number 4 asks, if the river is not moving at all, and if the boat is 2 meters per second, how long do you expect it to get to the other side? Okay, you can look at the simulation, and it says 0 and 16. Okay, so in number 4, we know v boat, and I'm going to say that's Vx is equal to 2 meters per second. X naught x, where the boat starts, is 0. So the boat starts over here. And x naught, whoops, not x naught, xx, the boat's final position, is equal to 16. There's no acceleration, so I can use my first equation, xx. And notice it's the same first equation, except I'm putting an x underneath everything, equals x naught x plus v naught x t plus 1/2 ax t squared. Okay, again, there's no acceleration, and I can go ahead and plug in 0 for x naught x, xx plus 2, and actually I need to put 16 in for xx, so 16 is 2t. We can solve for t, and t is equal to 8 seconds. And you can actually test that out on the simulation. Okay, number 5, it asks a bunch of questions. So it asks, first of all, now the river is 3 meters per second. And remember, the river's moving downwards, so I'm going to say Vy is equal to 3 meters per second. And the velocity of the boat, Vx, is equal to 2 meters per second. What do I expect to see the boat do? Sketch a diagram. Okay, so what I expect to see, and I'm going to doctor my picture over here, is I basically expect to see the boat move at some sort of diagonal. Okay, so that was A. In B, it asks, how long will it take to get to the other side? So here's the tricky and interesting part. We only need to think, since the other side is in the x direction, we only need to consider our x information. So we already solved for how long it was going to take to get to the other side, and we know that it took t equals 8 seconds. See, the total speed, again, Vx and Vy make the size of a right triangle. So I have a right triangle with 2 and 3, and the total speed is the hypotenuse, so I know that v squared equals 2 squared plus 3 squared. And if I solve for v, I end up with 3.6 meters per second. Alright, so in D it asks me about the direction with an angle of the boat's movement. So I can use inverse tangent, and I'd use inverse tangent of opposite, so that's the 2 over adjacent, 2 over 3, and I end up with 33.69 degrees. And in part E, it wants to know how far downstream from where it started should it end up. Okay, so I'm going to draw you a picture. Our boat started here, and it's going diagonally across, and we are really looking for this distance. Okay, so we're really looking for xy. X naught y was equal to 0. That's where it started. And you might say, hey, I have no idea how to do this. The crucial piece of information that we have is that we know t equals 8 seconds. Okay, we also know that Vy is equal to 3 meters per second. So we can set up our usual kinematics equation. Xy equals x naught y plus v naught y t plus 1/2 ay t squared. Okay, so I'm going to go ahead. There's no acceleration in this problem. I have xy is what I'm looking for, so I'm going to leave that as a variable. X naught y is 0 plus 3 times 8, and I end up with xy is equal to 24 meters. And you can actually go ahead and test that out on the simulation. Okay, so the next thing we're going to do is we're going to try something a little bit more difficult. So what I want you to do is flip over to page 6 in your packet, where it says Gabi is kicking a soccer ball. And we're going to talk about how to solve two-dimensional kinematics problems if there is acceleration. Okay, so first I'm just going to read through and draw a picture. It says Gabi is playing soccer. So here's Gabi, and he kicks a ball. And I know that the ball has a velocity of 5 meters per second. Okay, that's the total velocity. And I know that my angle, and I'm just going to make a red dot for my angle and say my angle is equal to 15 degrees. In part A, it asks me if the ball's initial x component velocity is 5 meters per second. Okay, so it looks like I made a small mistake. I know that the x component, so this is 5 meters per second. A, what's the initial y velocity? So that's part A. What is Vy? Okay, to do this, I'm going to redraw my triangle a little bit bigger so that it's easier to see. So I have 15 degrees. I have 5 meters per second. And I want to know the y velocity, so that's this side of the triangle. And I know that Vy is my opposite side. Okay. And I can just use SOHCAHTOA to answer this question. I have the opposite and the adjacent, so I'm going to use tangent. I know that tan 15 is equal to Vy divided by 5. So I can solve that as Vy equals 5 times tan 15. And when I plug that into my calculator, I end up with Vy is 1.34 meters per second. Okay, never forget that meters per second. In part B, it asks how long will it take the ball to make its maximum height. Okay, and I'm only going to do parts A and B for right now. So what I'm going to do is kind of like before, I'm going to make a list of my variables, except this time I'm going to have two lists. And when you have two dimensions, you always want to do this. So I'm going to have x naught x, x x, v naught x, vx, ax, and then x naught y, xy, vy, vy naught, or v naught y, vy, and ay. Okay, so again, this is all of your side-to-side motion. This is all of your up and down motion. You might be saying, we're missing something. Shouldn't I have t on both sides? And we do have time, but time is the same for both, and you'll find that time links our two equations. Okay, so I'm going to go ahead and think about this problem and fill in everything I know. Okay, I know that it starts, I can call this initial position 0. Okay, and it starts at the ground, so x naught y, the height, is also 0. Xx, I don't know how far it gets by the time it's at the top, and remember that's what we're wondering about in part B. So that's a question mark. And Vy, that's also a question mark. V naught x, we know, is 5 meters per second. And we just found V naught y is 1.34 meters per second. We don't know Vx, okay, because at this point it's still going to be going to the side. What the ball is not going to be doing at the very top is moving up and down. So it turns out that Vy is equal to 0 at the very top, because the ball is not at the very top, so at this blue dot is not moving up and down. In terms of acceleration, it turns out that in the x direction, if something's moving through the air, there's no force on it. And so we say ax is 0, and ay is from gravity, because gravity pulls it down, not to the side, is negative 10. Okay, so in part B, you know, we kind of spent a while making our list. You might forget at this point, what are we actually solving for? We're looking for how long it takes to reach its maximum height, so we're looking for t. Okay, and the next thing you're going to do is you're going to look at each side. So you're going to look at all of your x information over here and all of your y information over here, and you're going to say, on which side do I have enough information to solve for time? Because you can never mix your x equations and your y equations, okay? Your equations are going to have all your y information or all your x information, but not the two mixed. So, looking at this problem, we have more information in the y direction, so that's what I'm going to use, okay? And I know initial velocity, I know final velocity, and I know acceleration. So what I can use is I can use the third equation, but again, it's going to be Vy equals V naught y plus Ay t. I'm looking for this time. My final velocity in the y direction is 0. It's equal to 1.34 plus negative 10 t, and I'm not going to do all of the algebra for you, but if you solve for t, you should end up with 0.134 seconds. Alright, so the next thing I want you to do is I want you to spend 5 minutes, and only 5 minutes, trying to solve the second problem. Okay, go through the same type of steps. Okay, importantly, you're going to draw a picture first. And then second, you're going to make a chart with x and y. And you're going to find x naught x, x naught y, xx, xy, v naught x, vx, ax, v naught y, vy, ay. Okay, and then you're going to try to solve the problem. So spend 5 minutes doing that, and then come back to this video. Okay, now that you have tried the problem for yourself, we have Ross, and he's rock climbing. And this is the rock that he's climbing on, and, you know, he's attached to the rock, whatever. He throws a backpack, or he throws a rock to his friend, and it says he throws the rope horizontally. If somebody throws something horizontally, that means at the beginning, when they're throwing it, all of the velocity is in the x direction. It's all side to side because, remember, horizon is side to side. So, in the beginning, he throws something horizontally. If all of the velocity is in the side-to-side direction, that means our initial y velocity, our initial up and down velocity, is 0. Okay, it tells us he throws it with an initial speed of 4 meters per second, so that is our v naught x. And at the end, we want to know how far away from the cliff does it land. So we want to know what is xx. The other thing that we know is we know his initial height, so x naught y is 12 meters, because he starts 12 meters above the ground, and we know it ends up at a height of 0. So think of these x naught y and xy as height. We also know, because gravity is acting on it, that ay is negative 10, and there's no force in the x direction, so there's no acceleration in the x direction. Okay, we can set x naught x equal to 0, and what we really want at the end is xx. Just like last time, I'm going to look at which side gives me more information, and I'm going to use whatever that is to solve for t. And in this case, I have enough information in the y direction to solve for t because I just have more information there. Okay, so often what you want to do is see which side has enough information, solve for t, and plug it into the other side. And that's what we're going to do here. Okay, so we're finding t. Oops, I can't spell find. Find t. And looking at my y information, it looks like I can use my first equation. So I have xy equals x naught y plus v naught yt plus 1/2 ayt squared. Okay, again, there's no initial speed in the x direction, so that goes away. And I know that my final height is 0, so xy goes away as well. So I end up with 0 is equal to 12 plus 1/2 negative 10 t squared. Okay, so I have negative 12 equals negative 5 t squared, and t squared is equal to 12 over 5. I'm just simplifying the algebra. If you need to slow it down, work through these steps yourself. And you can hear motorcycles driving by my house. Okay. Then I take the square root of both sides. When I do that, I end up with about 1.54 seconds. Okay, so I found t. Now I can use that in the x direction. And actually, because I want xx at the end, I can use the same equation. So xx equals x naught x plus v naught xt plus 1/2 ax t squared. Okay? I know that x naught x is 0 and acceleration in the x direction is 0. And I end up with xx equals v naught x, which is 4 times 1.54, and I get 6.2 meters. So what that's really saying is he throws the bag and it ends up 6.2 meters from the cliff. Okay, so don't worry if this is still a little bit confusing, but hopefully you have seen the basic process. The main idea is that we break everything up into x and y, that's side to side and up and down. Alright, have a good weekend, and I will see you on Monday.